Hello everyone, so today I'll introduce the updated IB chemistry syllabus and explain the differences between year 1 and year 2, focusing on how this structure helps you build a strong understanding in chemistry. Then we'll dive into the fundamental concept of today, which is measuring energy changes and reactions. So in the IB chemistry revised syllabus, topics are much more integrated and organized to help you connect concepts between different areas of chemistry. So there's also a greater emphasis on real-world applications like sustainability and green chemistry, as well as more opportunities for you to develop lab skills and critical thinking. So the syllabus has two main sections, which is the core topics and the advanced topics for HL students. So in year 1, we'll be focusing on the fundamental building blocks. So we'll be talking about measuring enthalpy changes, and also energy cycles. Part of this energy cycle is only for HL. And then in week 2, we'll be talking about energy from fuels. Entropy and spontaneity is only for HL. And also the rate of change, we'll talk about the basics of kinetics and so on. In week 3, we'll be focusing more about kinetics, and the part of this is only for HL, so just keep a note. So in year 2, we'll be focusing on more complex topics. We'll be doing functional groups, classification of organic compounds. Part of this is only for HL. And then in week 2 and week 3, we'll spend some time going over previous concepts and doing some practice problems in preparation for paper 1 and paper 2 exams. So without further ado, I'll dive into the topic for today, which is energetics, measuring energy changes, exothermic and endothermic reactions. So first of all, reactions that involve energy changes. So we need to differentiate between physical change and chemical change. So physical change is the change in form or appearance of a substance, but not in a chemical composition. So it means that the substance itself remains the same on a molecular level and no new substances are formed. And physical changes are often reversible. Like for instance, melting and condensation, it's just a change of state, but the molecular composition didn't change, right? As well as chemical change. Chemical change is change that results in the formation of one or more new substances within different chemical properties and chemical composition. This process often involves breaking and forming of chemical bonds, which results in permanent change, and this is not very easily reversible. So examples of this is photosynthesis and oxidation. So just a review of what chemical change and physical change was. So what happens in a reaction? So in a reactions, it happens where bonds in the energy reactants break and new bonds in the products form. So this process happens simultaneously. So when bonds in the reactions break, energy is used, right? And in new bonds form, energy is released. So all reactions use and release energy. This is very important to note. And so what is endothermic and what is exothermic? So endothermic reactions is when the energy used is greater than the energy released. So as we looked in the previous slide, all reactions use and release energy simultaneously. But for some reactions, energy used is greater than the energy released. So therefore, energy is absorbed overall. So this is the net that we're talking about. And when this happens, this is called an endothermic reaction. So let's look at a different case. So when energy released is greater than the energy used, this is when the energy is released overall. So in this case, we'll call this reaction exothermic. So let's talk about system and surrounding. So the system is the chemicals in the reaction, and the surrounding is everything else. So in the law of conservation of energy, it states that the total energy is conserved in the chemical reaction, which means that the energy change in the system is equal to the energy change in the surroundings. So therefore, energy is not lost or newly created, but it's just transferred between the system and the surroundings. So we can see that, for instance, if we have a cold pack put on our arm, some energy is going to be transferred from our body to the cold pack, right? So energy is not lost or newly created, but it's just transferred. So let's look at the system and surrounding exothermic reaction. So energy is transferred from the system to the surroundings. Energy is released by the system and gained by the surroundings. For instance, a candle. So in the candle, energy is released. Where is the energy released? The candle releases the thermal and light energy, right? And what about the surroundings? The surrounding temperature, surrounding air, surrounding temperature, it increases, right? So therefore, the surroundings absorb the released thermal and light energy, right? Yeah, and so let's take a look at what endothermic and exothermic reactions are. So first of all, endothermic, state changes like evaporations and melting is endothermic. And thermal decompositions, cracking of alkanes is also endothermic. Exothermic, meanwhile, is condensation and solidification. Combustion reactions and neutralization reactions between acids and bases are also exothermic reactions. So now let's look at enthalpy. So what is enthalpy? So enthalpy is the heat content of a substance. Enthalpy is the total internal energy of a substance, including potential energy as well as kinetic energy. So the symbol of an enthalpy is the H symbol, the symbol, and the units are joules or kilojoules. So we need to note that absolute enthalpy values for any given substances cannot be measured. So enthalpy changes can be measured. The difference between energy delta H, we call it, enthalpy change can be measured, but absolute enthalpy itself cannot be measured. So we're going to measure enthalpy by enthalpy change, which is enthalpy of the products minus enthalpy of the reactants. This is called enthalpy change. So let's look at enthalpy change in endothermic reactions. So endothermic reactions are reactions that absorb energy, right? So therefore, the energy state of the products is higher than the energy state of the reaction. So the delta H will be positive, right? Will be going up. So the energy of the products is greater than the energy of reactants. And we can note this by the positive delta H. Meanwhile, exothermic reactions are reactions that release energy, and therefore the reactant state is higher than the product state. So we can note that the enthalpy change, which is the enthalpy of the product minus the enthalpy of the reactant, is what? Negative, right? So the enthalpy of product is smaller than the enthalpy of reactants, and we can note this by the negative enthalpy change. Okay, so let's look at an example of what it looks for enthalpy change. So in example 1, when 1 mole of water evaporates, 45 kilojoules of heat energy are absorbed. So if we note this as a reaction, as equation, we can write this as this, right? So the water vaporizes, and how much of energy? 45 kilojoules, right? So 45 kilojoules of energy is absorbed in the reactant side. So we put it here on the reactant side. So we can also write this as this part, liquid to gas, and the endothermic change is what? Positive, right?